Okay, so the problem I chose to do was problem 7-15, which can be found on page 376. It states draw the shear and moment diagrams for the beam. Here's the picture here. The first step I took when it came to doing this problem was first draw the original problem again, then draw the free body diagram of the beam. So in a free body diagram, you have a pin here at A and a roller here at B. So that's going to give you a reaction force AX, AY here, and then just BY here, along with your 6 kilonewtons and 12 kilonewtons in the middle of the beam. I then followed down, I solved for the forces on X. There's nothing else acting within the X direction, so your AX is going to equal 0. Do the sum of forces in the Y direction of this free body diagram. You can then solve for AY, where AY is going to end up equaling 8 kilonewtons. But right here, I actually skipped a step. You have this BY to also solve for, which can be found by doing a summation of the moment across A, which is going to be negative 6 kilonewtons times 2 meters minus 12 kilonewtons times 4 meters plus BY times 6 meters equals 0. You can then solve for BY. BY is equal to 10 kilonewtons. So when you go back to the AY, AY is then just the 18 kilonewtons minus your BY, which we found was 10, to get 8 kilonewtons for your AY. After noticing this, I knew I needed to start solving for my shear forces and my moment bend. So I redrew my free body diagram with the cut. So you have your AX, AY. I went ahead and drew a point for C, where the 6 kilonewton hits, point D, where the 12 kilonewton hits. You have your BY here, along with your shear and moment. If you do the summation of Y of this free body diagram, you can then take and solve for point VA, so shear at A, and get shear force of 8 kilonewtons. Then if you take and do the summation at A, you can solve for A to be 0. And as you can see, I have this arrow kind of indicating down here where I did the rest of the calculations were, here's my shear forces, my moment bends, and at different points is how I put it. That's how my brain thinks. So at B, if you did summation of forces at B of Y, you'd find VB is equal to 0. That's because what's happening is I'm going at point B and looking only to the right. There's no other forces besides your V, so your VB is going to be 0. If you look at point C, right here, you'll notice you have your negative 6 kilonewtons, negative 12 kilonewtons, your positive 10 kilonewtons, and then you'll have what's VC. So you can solve for that and get VC equal to 8 kilonewtons. Then at your point D, which is your last point for your shear force, you'll have your VD minus your 12 kilonewtons plus your 10 kilonewtons, and that's it, because it's only to the right. So VD is equal to 2 kilonewtons. Then you can do the same thing for moments, where it's going to be a moment about each individual point amongst the free body diagram. So we always solve for your moment at A, which is right here, it's equal to 0. Your moment at B is going to be your negative AY, it's right here, 6 meters, so right here, plus your 6 times 4 meters, plus 12 times 2 meters, plus your moment at B. Set that equals 0, you can solve for MB, and MB is also going to be 0. So moment here and here are the same. Then you can do your moment at C. So you have MC minus your AY, 2 meters. So it's going to be your AY, 2 meters. And you can solve for that. That's going to be 8 kilonewtons times 2. So 16 kilonewton meters for your moment at C. Your moment at D is then going to be your MD minus your AY, 4 meters plus 6 kilonewtons times 2 meters. You can then take and solve for that, where MD is going to be equal to 20 kilonewtons. Once you have all these total of 8 pieces of information with all your VA, VD, VC, VD, and your moments across each point, you can then take and draw your shear and moment bin diagrams, where you can see I labeled each point, went ahead and kept it 2 meters, 2 meters, 2 meters, just like as shown here. So for your shear, your VA, since it starts at 8 kilonewtons, you'd start here. Your VB drops to okay, so sorry for the cut. I just realized I messed up on my original deal. I put VA, VB, VC, VD because it's just how my brain works. When I actually have VA, VB, VC, VD. So these points are in the wrong spot, but the drawing's still done right. So you have your 8 kilonewtons from here to here. So that's going to be from your A to C. Then from C to D, which is another 2 meters, it drops down to 2 kilonewtons. Then from C to D, you're going to see it drop down to -10 and then jump back up to 0 towards the end of the shear moment. For the moment bin, it's the same thing. I did MA, MB, MC, MD, which it's wrong. Your MA's here, your MB's here, MC, MD. But as you can see, we already saw for MA, MB, MC, MD right here. So your MA starts at 0 kilonewtons. So does your MD. Your MB goes up to 16 kilonewtons. So you're going to have a slope here. Then you're going to have a smaller slope going from MB to MC, because it's going from 16 to 20. It's only a 4 kilonewton rise. And going from MC, or your MD to your MB, this last 2 meters, it's going to have a sharp drop because it's trying to reach back to 0. All in all, this is how I solved this problem. Sorry for the mistake on my namings here, but I hope you guys understand the point. Thank you.